Okay. We have the demand curve, we have the supply curve, and I've told you that we're going to try to figure out, well, what's going to happen to prices? Because in both of these, I basically said, hey, what if the price was this? What would happen on the demand curve? What would happen on the supply curve? But I haven't told you where the price actually comes from. Okay, so that's going to come from this idea called equilibrium. We're going to look for equilibrium in the market. We're going to be able to take the demand curve and the supply curve and put them together, and we're going to figure out sort of where the market seems destined to go based on the interaction of those two sides of the market. What's going to actually happen? So what is equilibrium, first of all? So equilibrium, you can also think of it as being there's no cash left on the table. All the opportunities have been exhausted. Equilibrium says when the market is in equilibrium, there are no unexploited opportunities for individuals. What does that mean? That basically says that nobody can make themselves better off than they already are. So, for example, let's say that in this classroom, we got some buyers, we got some sellers. We're still talking about chairs. We really like chairs. And let's say that I'm over here. I haven't bought a chair yet. I value a chair at 30 bucks. And there's somebody sitting out there who has a chair to sell, and their cost of production was 35. There's a possibility that we can make a deal here. Their costs are 35, my benefit is 40, we can come to an arrangement. If that hasn't happened yet, if we're still sitting out there unmatched and without a sale between us, then we're not in equilibrium yet, because we can make each other, because I can make myself better off by buying their chair. They can make themselves better off by selling their chair to me, right? There are opportunities left in the market that are unexploited. Then we meet, I buy the chair, there's no more chairs left to buy, or at least nobody willing to do it. There's nothing left to do, right? Everyone has already done everything they can, and that's when we're in equilibrium, when there's no more sales left to make that anybody wants to. How can we do that? How can we apply this idea of equilibrium, finding where nobody can make themselves better off, to find out where the market is going to go? Turns out to be very simple. We take the demand curve, we put it on the graph. We take the supply curve, we put it on the graph, and we look for where they intersect, and we're done. And that's it. Y'all get eggs. So yeah, that's it. We're going to look for where it crosses. And that's going to be where the market is going to go into equilibrium, and there's going to be no more opportunities for people to make themselves better off. So why? Why is it that simple? How can it possibly be? Let's walk through the logic. Then I don't want you to take this for granted, right? I want to prove to you that this indeed is going to be the place where the market's going to come to rest. Right? That's going to be where equilibrium is. Nobody's going to want to deviate from that spot. So remember, supply curve corresponds to the marginal cost of the good. What they're going to give up. So what they got, and that's also the reservation price. You got to pay them at least whatever their costs are to cover their costs, or they're not going to bother making anything for you. So if we put the supply curve up here by itself, and we set some sort of price, right? So imagine this isn't the equilibrium price yet. We're just sort of saying, hey, what if this was the price? If this was the price, what would happen? If that was the case, we could follow this price over and see what the quantity demanded is. It's right here, right? As you plug the price in, boom, there's the quantity demanded. This sort of splits the supply curve into two different parts, right? You got this part down here. These are the people for whom their marginal costs are lower than the price, so it's worth it to them to sell something, right? The price is 50 bucks, cost me 35 bucks to make, so yeah, I'm going to sell it. And then up here, you got people who it's not worth it for. These people who say, hey, 35 bucks, sure, great, but it's going to cost me 60 bucks to make this chair. I'm not going to do it, right? So we've got people who want to sell this unit at this price, people who don't, right? Here people are current Uber drivers, here's me. Demand curve. Demand curve corresponds to the marginal benefit and also their reservation price as well. So what's the worst price that they'd accept? So as long as the price is below their marginal benefit / reservation price, they're happy, they're going to buy. So let's do the same thing. Here's a demand curve. If we pick a price, if this happens to be the price, we follow it over. There's our quantity demanded, right? We've split the demand curve into two. We've got people who are buying the thing and people who are not. People with boats and me, right? Still on the curve, but I'm not buying the thing because the price is too high for me. Now, let's put them together and let's imagine what would happen if the price wasn't where they crossed. Let's put it too high. Let's say the price is above the point where they're currently crossing. So what's happening here? We got this price. We follow it along. This is going to give us the quantity demanded, where that price goes into the demand curve, right? Because we know we follow the price until we hit the demand curve. That gives us the quantity demanded. We keep following it along until we get to the supply curve. That gives us the quantity supplied, right? Now what do we have? We have quantity demanded. We have quantity supplied. They're not the same. What does that mean? That means that there is what is called excess supply. There are more people who want to sell this thing than there are people who want to buy it. How many more people? Well, this many people want to sell, or rather this many units want to get sold, but only this many units want to get bought. So the gap between them right there is the excess supply. It's how many more units people want to sell than are willing to buy. So we have too many units being supplied, right? An excess supply. Confusingly, and I will try to avoid this term, but you will commonly see this referred to as a surplus, even though it is not the same thing as the economic surplus. Remember I said that term was getting confusing? Well, here it is. I'm going to try not to say it. I'm going to try to call it excess supply all the time. If I mess up on that, let me know. We have an excess supply. So what's going to happen here when we have too many units people want to sell? So first of all, there's obviously going to be some unexploited opportunities. Remember I said that equilibrium was all about when there's no opportunities left to exploit? Well, here we have opportunities left to exploit. Imagine that you're sitting right here on the demand curve. Your marginal benefit is just a little bit lower than the price. At the current price, you're going to say no, but if the price went down a little bit, you'd say yes, right? You're the person who goes to the store and says, it's just a little bit too much for me, I'm not going to buy. So you're sitting here thinking, I'm not going to buy right now, but hey, sellers out there, I'll buy from you. You just got to lower your price a little bit for me, right? That's all you got to do. And the suppliers are saying, hey, I prefer this high price. Like I want to sell for more, but actually this price, this really high price, nobody's buying, right? I would love to sell at this high price, but I can't find anybody to sell to. So fine, I guess I'll lower the price. Fine, you're bending my arm. You're going to make me do it. And they're willing to do it because otherwise they're just sitting around with all this stuff they want to sell, but they can't find anybody to sell to. So the supplier down here who currently would like to sell at the high price, but can't find anybody, will be willing to lower their price. And so is everybody else down here, right? Because only a couple of them are making any sales. The rest of them are going to be willing to lower their prices to sell all the stuff they got. So the price comes down. Market price comes down. Now, no individual had really control over this, but it was sort of everybody as a whole saying, yeah, I got to lower my prices because otherwise I can't sell this stuff, right? And as soon as somebody else does that, you have to lower your prices too, even if you were already making sales, because otherwise no one's going to buy from you, right? No one's going to buy from the person with the highest price. So the price comes down. Now the price is down here. Problem repeats. Here's the quantity demanded. Here's the quantity supplied. They're still not equal. So you're still going to have sellers out there saying, hey, I love this high price, but I can't sell my stuff at this price. No one's buying. And you still have consumers out there saying, hey, that high price is just a little bit too high for me. You got to lower the price. And so again, the exact same thing is going to happen. People are going to be willing to lower their price so they can actually sell all their units. You end up right here, which is, as I said, the equilibrium point. At this point, quantity supplied and quantity demanded are the exact same. There's nobody out there who has an unexploited opportunity. Now you might say, well, what about these people on this side of the graph? They're not doing anything right now. Well, you can imagine what would happen. Maybe there's people out there thinking, okay, well, the price is right there. Why don't we just lower it a little bit more? Or hey, why don't I start getting in if the price just changed a little bit? All these consumers down here, they'd be willing to buy if the price went down a little bit. Sure, fine, great. But these are the units that haven't been made yet. Every additional unit past this point is going to cost more to make, because here's the marginal cost. Remember, this marginal cost is on the supply curve. It's going to cost this much. People are only going to be willing to pay this much for it. So the supplier is not going to be able to cover their cost. It's not going to be worth it to them. So all these people in the market, with the lower valuations on the good, who get the lower marginal benefits, they're not going to get sold to, because they're not willing to pay as much as it costs to produce. So that's where it's going to stop. We're going to stop right here. The price is not going to drop any further. Now, the same logic works if the price is too low, just in the opposite direction. Price is too low. This time, instead of excess supply, you can guess what's going to happen. Excess demand. We have too many people who want to buy the thing. Price is down here. Here's the quantity demanded. Here's the quantity supplied. People want to buy a bunch of units, but nobody wants to sell it to them. This is describing any time there's ever been like a rush on something, right? So, you know, the hot Christmas gift or whatever, and it sells out immediately. It's because the price is down here. You have a bunch of people who want to buy the thing, not as many units getting sold or getting produced to be able to cover all the units people want to buy. This is also known as a shortage. So when we have this, we have what's called excess demand or a shortage. People want to buy more units than there are units to buy. And the same logic works, right? You have all these suppliers out here who are saying, you know what, the price is right now too low for me to bother to sell any. But if the price came up a little bit, yeah, sure, I'd sell them. And you've got a bunch of consumers out there who are saying, well, I really like how low the price is right now, but I can't find one. So yeah, sure, if you raised your price a little bit, I'd still buy the thing. And so they have an opportunity there that is unexploited. So the price is going to come up a little bit. There's enough people out there willing to pay that higher price. And so price goes up. And then that keeps going up and up and up until you reach back to the point where quantity supply equals quantity demanded, and there's no unexploited opportunities left to have. Okay, here's what we're going to do. I'm going to preview how the math on this is going to work. We're going to do like one example, and then we're going to leave the actual work of this for the next time. So I've told you that you can graph this out, find where they intersect, and that's going to be your equilibrium. How do we actually do that in such a way that's going to give us an answer? Thankfully, some pretty basic algebra. If you remember any algebra at all, you will know how to do this. And the math in this course does not get that much harder than this anyway. So how can we figure out what our equilibrium price and quantity actually are? Oops, hope they didn't need that. So the nice thing, so something that will help you in the math in this course is to remember that a line or any sort of shape on a graph is some sort of equation or relationship, right? If I write out, let's say y equals x, that's a very basic formula, right? And what a line is it's just describing all the points for which that formula is true. Okay, so I can say, well, here's a point right here. This is, let's say this is an x of 10 and a y of 5. Is this true for that? No, so I'm not going to fill it in. Okay, well up here, maybe this is an x of 9 and a y of 9. Is that true for that? Well, then yes. Okay, that's going to fill in. I just keep doing that until I get my line, right? So a line or any sort of shape is just describing an equation, right? All the points for which that equation happens to be true. So why am I telling you that? Because what this means is that any time you're looking for the intersection between two lines or two shapes, you're just looking for a point where both of those equations are true at the same time, which is what we're doing, right? So I'm going to give you an equation to represent demand. I'm going to give you an equation to represent supply. And to find their intersection, we just need to figure out when those two lines are true at the same time, which is solving a system of two equations. And this is also going to apply for all the other models that we do in the class. For example, I'm going to give you a preview. This is not a model I'm going to teach you right now. I'm just going to draw a graph of it. You're not going to know what it means. That's fine. Okay, that's a graph that we're not going to see until after the midterm, but it doesn't matter, right? If I told you, hey, the answer to this question is the point where marginal cost and demand cross. It's right there. How would you solve that? Well, you take whatever the equation was for MC, you take whatever the equation was for D, and you solve them together for X and Y. And that's it, right? Anytime we're looking for an intersection, which by the way is going to be the answer for pretty much every graphical question in this course, you're looking for the intersection between two lines, you're just solving them together. Plus, as a bonus, if the line is like flat or vertical, that's also an equation. It's just a single number. So this, let's say this is a price of, 10, right? What's the marginal cost on the x-axis at a price of 10? Well, we have one equation here. We have our y-axis, or P equals 10. We have whatever our marginal cost equation is. Solve them together. Plug P of 10 into our marginal cost equation. It's going to give us the answer. Anytime you have an intersection, whether it's for a swoopy equation, straight line, vertical line, whatever it is, you're just solving two equations together. That's it. So let's do that for supply and demand. Okay. So I'm going to give you some equations to represent supply and demand. Remember, these are relationships between price and quantity. So here's our demand curve, for example. It's got price over here. It's got quantity over here. Quantity demanded specifically, QD, showing you how they're related to each other. Every time QD goes up by 1 unit, price goes down by 2 units, right? Negatively related, because demand slopes downwards, right? Here's supply. Every time quantity supplied goes up by 1 unit, price goes up by 1 unit. Or conversely, every time price goes up by 1 unit, quantity supplied goes up by 1 unit. Either direction is fine. Positive slope, since supply slopes upwards. Okay. We've got our equations here. We can graph them out if we wanted. You know, here's demand, here's supply, and we want to find that equilibrium point where they intersect. So we're going to solve them together. So the first thing we can do, we're going to be looking for something called P star and Q star. That just means the price and quantity at equilibrium, right? Because we know that at equilibrium, we're talking about the same price and the same quantity, right? At this dot here, we're only talking, there's only one price, there's only one quantity. It's this one, P star, and this one, Q star. So all the prices and quantities we have here, we can replace them with just that one P star and that one Q star. So we got P star equals 30 minus 2 Q star, and we have P star equals 15 plus Q star. What is this? 2 equations, 2 unknowns, P star and Q star. We can solve that. The easiest way to solve this generally, because pretty much all of our equations are going to have one thing over here, just price. That's going to make it pretty easy, right? But by the way, if I ask you for what demand is, and you say it's 30 minus 2 QD, that's wrong, right? Because that's not a relationship between price and quantity demanded. That is a relationship between price and quantity demanded, right? You gotta have the whole thing. Okay, so let's solve this out. We know that P star is the same as P star. Hopefully that one is intuitive for you. This one comes from here. This one comes from here, but they are the same thing. That means that 30 minus 2 Q star equals 15 plus Q star. Right? Now we have one equation, one unknown. We can solve that. So we're going to subtract 15 from both sides. We got 15 minus 2 Q star equals Q star. We can add 2 Q star to both sides. Now we got 15 equals 3 Q star. We're running out of room, but that's fine because we just divide by 3 on both sides. We get that Q star equals 5, which we can now write in on our graph. There's our 5. Now we just got to figure out what price is. All we got to do for that, take the Q star that we have, plug it back in. For either one of the equations, it doesn't matter which one, you should get the same answer either way. And in fact, that's a good way to check your answer. If you try it in both of them and you get different answers both times, you know you haven't found the equilibrium. So let's plug it back in. So we have a price P star is 30 minus 2 times 5, right? That comes from here. So we get P star is 30 minus 10, or let's just call that 20. Let's check our work, make sure we didn't make a mistake by going on the other equation as well. So we got P star equals, from this one now, 15 plus 5, which is going to be 20 as well. So we did it right. So that's how we can figure out what the equilibrium price and quantity are. And don't worry, you'll get plenty of practice on this one.